So we wanted to model this right here. Attendance is modeled by the home team. And we've started to get estimates now for the home team variables and how it impacts attendance. So that's what these estimates are trying to do. But to test if it's a real effect or not, something that's likely true given our question. We have a question, we want to try to answer it. So we want to measure if it's a real effect or not given our data set. We have to look at the F-test of overall significance for the model. And that's this F statistic reported at the bottom here. This F-test of overall significance, the F statistic here, gives us this p-value. And a p-value essentially, and always remember this, a p-value is just a measure of uncertainty about your data set. Specifically, the p-value is the probability of getting a positive result from your data set if there was no real effect. In shorthand, some people say the p-value is the probability of a false positive result from your data, positive conclusion, but it's not really true. And your ability to evaluate the uncertainty, that probability that you're comfortable with, is what the data scientist has to do with the data set. Now I'm going to show you this p-value in our data set here. It's 2.2 times 10 to the minus 16th. It's an extremely low probability. It's a very small likelihood that we would say the home team does not impact attendance. In other words, there's a very high likelihood that the home team does impact attendance. But this makes sense intuitively if you're a baseball fan. We talked about big market and small market. Look at the estimate coefficient for the New York Yankees. 10,000 higher than the reference estimate that we started with Anaheim. Okay? So we're starting to build a model where we can actually estimate. We can estimate now with our model what attendance is going to look like based on the home team. And here's what the model looks like. The model is that attendance equals our first estimate from Anaheim, 36,451, plus all of these other estimates. If it's Arizona, we subtract this estimate. If it's the White Sox, we subtract this estimate. If it's the Cubs, we add this estimate. All of these things now estimate our final attendance of any given combination of the home team. So we can just go say, well, what's the average attendance for Cleveland? Well, it's 36,451 minus 79,53 in our data set. So we not only have approved that this model actually is important, home team does impact attendance, and it does predict attendance. We now have an estimate of that prediction. We can estimate now how the home team does impact attendance. And that's what all these estimates are here. They tell us how attendance actually gets modeled given our data set. So again, going down to the F-test of overall significance, we have a very low p-value, which tells us that this model is important and it does explain how attendance works, at least in part. But that's what multiple linear regression does. We start looking at all these different estimates and we start adding different components to our model.